Hello, it is my pleasure to be with you this time. We are going to consider a different subject and a different topic. The subject is physics. Physics is one of the major science subjects, okay? And then the topic we are going to consider is a simple one indeed, and that is a series connection of resistors. The topic we are going to consider is a series connection of resistors in an electric circuit, okay? An electric circuit. Circuit arrangement of resistors in an electric circuit. What it means is how number of resistors can be arranged in an electric circuit using this series method, okay? Now, before we delve into discussing this comprehensively and extensively, we need to understand the meaning of a resistor, okay? So we start with the meaning of a resistor. The meaning of a resistor, okay? A resistor is an electronic. It's an electronic component. It's an electronic component, okay, that offers opposition or resistance to the flow of current, current in a given circuit, okay? Okay, to the flow of current in a given circuit. All right, so that is the meaning of a resistor. What it does in a circuit is to offer some amount of resistance, okay, or opposition to the flow of current in a given circuit. All right, the next thing we are going to consider is the letter that can be used to represent the word resistor. So the letter here is resistor. Resistor can be represented, can be stated as R, okay? Capital R. So wherever you see capital R in everything, in whatever we do, you know that that R represents resistor. All right, then we need to consider another thing here. Having known the meaning of a resistor, we need to understand the symbol, or rather know the symbol of a resistor. So the symbol, okay? Symbol. There are about 3 prominent symbols that represent a resistor. One used by the United States of America, and the other one is used by United Kingdom or the Britain. Okay? So the first one, this is the first one. This symbol, US, R, okay? The second one, II, is another symbol of very importance. This is Britain or UK, okay? Okay, let's use the word UK. Okay? Another important symbol here, UK, right? Then the third one that we need to understand is what we call a variable resistor symbol. The same way I can use this or that to represent it. So we have something like this. Okay, let me use this one. to represent a variable resistor. Okay, we still have something like an arrow crossing it slightly. Okay, this is known as variable. Okay, it's a variable resistor. Now, if you look at these three symbols, you will see that this one is different. It is different because it is a variable resistor. Variable resistor. So it varies its resistance when it is given or functioning in an electric circuit. Okay, it varies. All right, or it can be varied in terms of its resistance. Then these ones are standard resistors. Standard in the sense that their values have been predetermined. You don't need to change them. But anything within this range can be what? Varied. All right. Okay. Now let's look at another important thing: the unit. The unit. The third one is the unit. The unit of a resistor is given as the ohms. The unit of a resistor. Unit of a resistor is given as the ohms. Okay, in bracket we have capital letter omega. Okay, omega is a Greek word. Okay, it is used to represent the unit of a resistor. So a resistor is measured in what? In the resistance of a resistor, please. The resistance of a resistor, please, is measured in what? In ohms. Okay, so that is it. And then last one we're going to consider is now this arrangement. Arrangement of these resistors. Okay, how this resistor or resistors can be arranged in series. So the fourth one is the series arrangement or series connection. Series connection, okay? All right. Series connection here is very simple. All right. We look at this. Suppose we have maybe 3 resistors with various resistances has been drawn. Okay? Alright? So this is R1. Okay, the first one is R1 resistor 1. The second one is R2 resistor 2. The third one is R3 with resistance 3. Okay? Alright. If there is a potential difference across each of these resistors, we have something like this. Then the next one, okay, we have something like this. All right. Okay, so that is it. So there is a potential difference across. There must be current flowing, right? Current flowing. This is very, very interesting. Very interesting. You can see we have 3 resistors connected in series. Now that brings us to the meaning of a series arrangement or connection of resistors. It simply means when you have 2 or 3 resistors connected end to end, just like a chain, okay? When they are connected end to end, that means they are said to be what? In series. All right. Now, having done that, the next thing we need to understand is this: how to calculate the total resistance, or you call it the net resistance or the equivalent resistance, okay, of the combined resistances from resistor 1, resistor 2, and the resistor 3. So we get that by using this formula. R, capital R, subscript, capital T is equals to R1, R2, alright, then we have R3, because there are 3 resistors, dot, Rn plus Rn, okay? So this particular formula now will help us to calculate, to find the net resistance of any number of resistors given in a series connection. Okay? Then the next thing is since we have only 3 resistors, we just narrow it down to RT is equals to R1 plus R2 plus R3. Okay? Remember that the unit of measurement of resistance is ohms. That's the sense of this. Okay? That's the unit of measurement. Alright, having done that, then the next thing we need to consider is what happens when resistors are connected in series. What do you think happens as current flows? as energy is deposited across each of these resistors. As they function in a given electric circuit, what happens? Just two things happen. Let's take note of that. All right? The two things that will happen, take note. One is that current I is the same. Current I, okay, is the same. All right? Okay? That is it. The current flowing is the same. Doesn't change. The second one we need to consider is II. This is II. Oh, this is too close. This is too close. Let me. Okay? The second one we need to consider is that the potential difference across each of these resistors is different. Okay? So the second one is, okay, we can take something from this point. III, the PD, this PD. PD stands for potential difference. The PD across each of them is not the same. It's not the same. Okay? Alright, that's what you need to know as a student, as a learner, that the current flowing in a series connection of different resistors is the same. Why the potential difference? The potential difference across each of them is different. I repeat that the current flowing is the same. Why the potential difference is quite different in each of them. Then let's look at a very simple exercise. Suppose we have, for the time being we are going to, okay, we have R1 is given as 2 ohms, right? R2 given as, rather R2 given as 3 ohms, R3 given as 5 ohms, right? Okay? Now you are asked to find the equivalent resistance, RT. You are asked to find the equivalent resistance, RT. What do? We recall. To find the equivalent resistance, we have a formula. RT is equal to R1, R2, and R3. Since we have 3 what? 3 resistors offering different resistances. Alright? Okay. The question might come in this form. 3 resistors of resistances 2 ohms, 3 ohms, and 5 ohms respectively are connected in series. Find their equivalent resistance. That is RT. So we have R1 plus R2, then plus R3. Okay? So with this formula, we have it. We use this formula, okay? We use this formula immediately. So by the time we add 2 plus 3 plus 5 will give us 10 ohms, okay? We have 10 ohms as the RT, okay? We have just what? 10 ohms as the RT. So we have RT is equal to 10 ohms. Alright? So you can see it's very, very simple. Alright. At this point, I want to especially thank you for your time and then urge you to subscribe to our YouTube channel at Levi Kingsley. Like our Facebook. Okay? Visit our social media handles, Pinterest, Reddit, Twitter, Instagram. Like it, and you will see many more of these come your way. Thank you for your time.